Hi everyone. Now in this video I am going to discuss about the projectile motion lecture 2. As earlier I have explained in the last video, projectile motion ground to ground and projectile motion from certain height to the ground and projectile motion on inclined plane, up the plane, down the plane, conditions for the maximum range I have given. Now, last video I have explained only JEE mains questions only. In this video, I am going to cover the JEE advanced related questions. Okay. Before going to do that, I will explain that some concepts like what is the condition for the collision between the two projectiles. Okay. I am writing now condition for collision between two projectiles. Let us consider that there are the two projectiles. One projectile is projected with velocity u1, another projectile is projected with velocity u2, and these angles are projection angles are theta 1 and second projectile is theta 2. The separation between the two projectiles is d. I am treating the first projectile starting from A, second projectile starting from the B. Now they are just taking a parabolic path. Somewhere they collide. They will collide somewhere. Now what should be the condition to collide? Okay, the condition is to collide there should not be any relative velocity along the line perpendicular to line joining between initial positions of the two projectiles. Observe this carefully. The condition should be actually whenever they are colliding, you can see when they are colliding, they are coming like a horizontally. Nothing but there should not be any relative velocity perpendicular to the along the line perpendicular to the line joining between initial positions of the two projectiles. Okay. If we use these relations, we can write it as u1y should be equal to u2y. This is the first condition. Now, what is the time? At what time they collide? They collide at time t is equal to separation between two particles. Separation between initial positions of the projectiles of projectiles, here AB, whole divided by the relative velocity along the line joining between them, along line joining between along AB, relative velocity along line joining between the initial positions, u12 bar along AB outright. This should be the condition to collide between two projectiles. The same thing if I take in other way, like if I projected from the certain height. If I project from certain height, let us consider the first particle is projected with velocity u1, second particle is projected with velocity u2. Separation between them, let us consider that I am taking as d is the separation between them. First projectile projected from A, second projectile projected from B. I am taking first one is theta 1 making with horizontal, and the second projectile is making an angle theta 2 with horizontal. Now we can see first one is located at height h1, second one is located at h2 height. We can see separation between A and B is h2 minus h1. Okay, now you can see in this case both will be going like this, and the first one is going like this. Somewhere they are colliding. When they collide, we can see our conditions. We can see what should be the our relative velocity. Okay, I am redrawing the diagram. You can see I can write the new angle phi, separation D, A, B. This is h2 minus h1. Our new relative velocity, this is velocity of the first particle with respect to bar is this. We can make the u12 x, and other one is relative velocity along the 1 2 with along the y-axis. Okay, now whatever relative velocity is there, now u12 bar, you see here the relative velocity is along AB bar. Okay, so I am using the same thing, u12 bar along the line joining between them, and the time of collision t can be written as, you can write it as distance AB divided by the u12 bar you can write. Similarly, whatever tan phi is there now, that tan phi can be written as h2 minus h1 divided by the d. That is also equal to u12 y-axis, u12 along x-axis. So this should be the tan phi. By using these two relations, you can calculate the time of collision also. Okay, observe carefully how to calculate the time of collision between two projectiles whenever they projected from the ground two projectiles, and when they are projected from certain height. You have to calculate u12 bar and proceed that, you will get the answer. Okay, next case I am going to one more method also, finding separation between minimum separation between the two particles. Finding minimum separation between two moving particles and time for minimum separation. That I am going to write now. Observe this carefully. Minimum separation between two particles and minimum time for minimum separation. Let us consider there are the two particles. I am taking A particle, B particle. I am taking A is moving with velocity VA along vertical direction. B is moving with velocity VB. The separation between AB value is equal to, you can see that D. If you want to calculate the what is the minimum separation between the two particles, for that what I am doing is, I am making this into a simplest diagram. See, I am fixing the B. I am fixing this. Just I am observing the position of A with respect to the B. Position of A with respect to B can be written as, I can write the VA B bar can be written as VA bar minus VB bar. As VB bar is towards the left side is there, minus VB bar will be right side. Okay, now you can see velocity of A with respect to B. How do you write this one? Magnitude of under root of VA square plus VB square. In this case we can write like this. Okay, now I am writing this velocity of the A with respect to B will go like this. Whenever velocity of A with respect to B like this is there, you just drop a perpendicular line from B to this VAB line. This is VAB line. Okay, I am writing here, drop a perpendicular line from one particle to relative velocity line. Okay, now I am taking this as a point C. I am taking this as a point C. Now you will calculate the theta value also. You can easily calculate now. Let us consider this is the theta. Now tan theta value is equal to, you can write it as VA divided by the VB is the tan theta. So separation between A and B is D. If it is theta, now you can write the 90 minus theta. If it is 90 minus theta, at B angle is equal to theta. Now whatever BC term is there now, that is a minimum separation. Minimum separation. Okay, I am writing here minimum separation. You can see it. Drop a perpendicular line from one particle to relative velocity line. That BC line gives minimum separation. Minimum separation between two particles. In this problem, what is the minimum separation? If you known terms are D, theta already calculated by using VA by VB. Now you can use the D is equal to BC is equal to adjacent side by hypotenuse. You can write. Okay, I am writing cos theta is equal to BC divided by the D. From this you can write it as BC is equal to D cos theta. This is the minimum separation. Next, what is the time for minimum separation? Okay, minimum separation you can see as the body is moving with velocity VAB from A to C it is moving. Okay, A to C, what is the time? Time for minimum separation. Minimum separation. We can write T is equal to AC. You can see in the diagram A to C is the minimum separation. Okay, AC divided by the velocity of A with respect to B magnitude value. Now if you write the AC value, you can write sine theta. From the diagram you can observe that AC is opposite side to theta. That's why sine theta is equal to AC by D. We can write AC is equal to D sine theta. You can use D sine theta divided by the velocity of A with respect to B. By using this, we can calculate the minimum time for the minimum separation. I am not telling you minimum time. I am telling time when the separation will be minimum. Okay, time for minimum separation means time when separation between particles is minimum. Between particles is a minimum. Okay, this is our relations. Now instead of this, if any projectile particles are there, then how to calculate the minimum separation I will write. Let us consider that there are the two projectiles. One projectile is A, other projectile is B. A is projected with U1 and B is projected with U2. Theta 1 and other one is making angle theta 2. Now separation between them, let us consider the D. As I told earlier, first you have to write the any particle. You fix the one of the particle. Okay, what particle I have to fix here? Let us consider B particle is fixing here. I am fixing the B particle. Okay, fix the B. Observe the A particle. So this is a velocity of A is U1 is that side and U2 is like this is there. If U2 is like that is there, you can upward direction like this is there. Now you have to write the reverse of this. What is the reverse of this? B will be like this. Okay, now I am making the same point I am writing here. B value how it is there in reverse direction. Okay, why? Because you want VAB bar is equal to VA bar minus VB bar is there now, that I am writing. Similarly, velocity of A with respect to B is equal to VA under root of VA square. Sorry, not like that. You cannot like this. As per the situation you have to follow. Why? Because they are not perpendicular. No, they are not perpendicular. You can write as per the relations. So this is a U1 bar And similarly u2 bar somewhere I am writing like this. How do you write like this? Now minus vb bar is downward direction is there. Okay, now I am writing like this, minus ub bar, which is making angle theta 2. Let us consider that the relative velocity is like this. You don't know, maybe down or upside is there. I am taking here velocity of a with respect to b is actually you can write velocity of first particle with respect to second. Okay, it is making angle theta. Okay, now you can see there is a perpendicular line somewhere. You can see there is a perpendicular line. This is d. I am making this as c. Separation between a and b is d. Now same thing, minimum separation is bc is equal to, we can write it as d cos theta. What is theta value? From this you can write it as u12 is there. Now that u12 will have two components. One is u12x, other one is will have the u12 along y-axis. Write that tan theta value is equal to u12y divided by the u12x. You will calculate the theta value from there. Okay, and you can write the d cos theta as a minimum separation. Next, time for minimum separation. Time for minimum separation. Minimum separation. We can write t is equal to time, how much distance it is traveling along the line here. You can say relative velocity line. It is traveling a distance AC divided by the magnitude of u12 bar. What is the magnitude of u12 bar? I can write the u12 bar magnitude is equal to under root of u12 x square plus u12 y square. Don't write va square plus vb square. Okay, under root of u1 square plus u2 square. It is not the under root of u1 square plus u2 square. This is ub bar I have written. This is not ub bar, minus u2. Okay, now from this you can write ac is equal to d sin theta divided by the magnitude of u12 bar. As per the question you can follow that values, you have to can substitute and get the answer. Observe carefully, I have given that two things like collision between two projectiles, time for the collision, and one more thing is minimum separation between the particles and time for minimum separation. Now I will just show you some of the JEE advanced question what they have asked from this chapter. Okay, first one, it is asked in 2011 JEE advanced paper 2. A train is moving along a straight line with a constant acceleration a. I am taking there is a train. Consider this is a train. In this train, now you can see this is moving with acceleration a. A boy standing in the train, so the person is standing here and throwing forward with certain velocity 10 meter per second, making an angle 60 degrees with the horizontal direction. Now this will take certain path now. So whenever it is taking certain path, according to question they have given, the boy has to move forward by 1.15 meters inside the train to catch the ball back at the initial height. Same height is actually catching. The acceleration of the train should be how much? You can observe that to reach this, actually whatever this point is there now, this boy has to move a distance of this, nothing but you can see boy should reach to certain point. How much point he has to move now? Train is moving forward direction. Now he has reached a distance of 1.15 meters. He has moved a distance of 1.15 meters. Now you can see what is a projectile actually. If you see that ux is equal to 10 cos 60 degrees for projectile, you can write the 5 meter per second. Uy value you can write 10 sin 60 degrees. You will get the 5 root 3 meter per second. How much time of flight will be there? Time of flight you can write the time of flight is t is equal to 2 into uy divided by the g, that is 2 into 5 root 3 divided by the as per the question, this is the g value, let us consider 10. Suppose if you take that t value, you will get the root 3 seconds. Now you observe that on the ball, so whenever this ball is moving from here to here, whenever ball is going like this, we can say ball will experience a pseudo force. This side pseudo force will be acting on this m into a. Nothing but this will be actually whatever acceleration is there, ax direction minus a is there on ball. Suppose with respect to the train frame, minus a is there, and he is covering a distance of 1.15 meters. I am writing what is the distance covered. X is equal to uxt plus half into ax into t square is there. He is covering 1.15 meters. Ux value already you have 5. T value is root 3. Acceleration is minus a is there. Minus half into a is a into t square is root 3 whole square. You substitute there, 1.15 is equal to 5 root 3 minus 3a square divided by the 2. 3a square by 2 is 1.5. You can write that 3a square divided by the 2 is equal to 5 root 3 minus 1.15. If you write that 1.5 a square is equal to 5 root 3 value is 5 into 1.732 is there. If you write the value, you can get the 8.5 minus 1.15, or a square value you can write it as 7.35 approximately I am writing divided by the 1.5, and a value is under root of approximately 7.35 divided by the 1.5, approximately you will get the 5 meter per second square. You observe this carefully, the value is okay. 3 by 2, if you write the 7.5, or also you can write approximately you can get the 5 meter per second square, or 4.9, like that you will get. Okay. Observe this carefully. I have explained that by using the general relations only. Next question. An object A is kept fixed at the point x is equal to 3 meter. This is a 2000 question, 10 marks. Initially, an object is located at 3 meters and y is equal to 1.25 meter. And a plank P is raised from the ground. You can see whatever this plank is there now. Initially, this plank is here. This is a plank. That plank is raised from here to here. Raised. It is raised from the ground to the top level. It is raised. Now, so that this plank is supporting for the object given A. A is like a one box type is there, you can see. Okay. Now, this is a given thing. See, plank starts moving along positive x direction with an acceleration of 1.5 meter per second square. This plank is moving with 1.5 meter per second square. At the time of instant, a stone is projected from the origin, means at t is equal to 0 is here and t is equal to 0, they are projecting any particle also. The velocity u bar is given. A stationary person on the ground observe the stone hitting the object during the downward motion. You can observe that during downward motion it is coming and hitting the object. All the motions are in the xy plane. Find u bar and time after which the stone is hitting the object. Now I will draw the diagram. You can see first. This is my x-axis, y-axis. Now at this point, you can see at y 1.25 meters, there is a one object is kept here. Somewhere here, one object is kept. To support this object, they have kept a plank. This plank is moving with 1.5 meter per second square. Acceleration at t is equal to 0. From at t is equal to 0, a particle is projected with u bar making some angle theta. We don't know that what angle it is making. This location, initial location is 3 along x-axis. Now this plank will move forward direction. Whenever plank is moving forward direction, still this acceleration is 1.5 meter per second square only. By this time, I forgot to write this object also there. Object also will have same thing. By this time, this projectile is there now. This projectile will go like this, reaching highest point. Then it strike this. Whenever it is striking, you can observe that it will have the certain velocity will be there now. That velocity, let us consider v. This velocity is making an angle 45 degrees with x-axis. Vx and Vy I am writing. Now see here, if I write the any velocity at any point while going up, if I write the velocities, I can write velocity Vy is equal to Uy minus Gt will write. And this is what here Vx is equal to Ux. Here also Vx is equal to x. Throughout the motion horizontal velocity same. But while coming down Vy value is equal to how much? Gt minus Uy. Why? Because velocity is downward direction is there. That's why I am writing. Okay, gt minus ui. Now you can see both the distances. You can see object distance. It is traveling a distance of half into a into t square. That is nothing but half into a is nothing but 1.5 3 by 2 a t square. 3 by 2 t square you can write. That is 3 by 4 t square. 3 by 4 t square. Now location of this can be written as x is equal to 3 plus 3 by 4 t square, as initial velocity of plank is 0, object also 0, and both will be reaching to certain height y. Okay, let us consider the first equation. Okay, next equation y is equal to, you can write it as uyt plus half into ay into t square. This is for stone. First one is for object. X is for object. For stone I am writing y is equal to uyt plus half ayt square. Uy value, that y value is already given. What is the y value? 1.25 is equal to uyt minus half into gt square. For stone ay value is equal to 0. Ay value is equal to minus g for stone. It is moving under the effect of the gravity. And again, apart from this, we can also see that stone also travels certain distance. Distance traveled by the stone. Traveled by the stone in time t. What is the time here? Wherever it is hitting, no, that you can write the at a time t. Okay, that I am writing. At a time t, you can write x is equal to uxt plus half into axt square. Now for stone, acceleration along x-axis is 0. We can write x is equal to ux into t. Let us consider this is the third equation. Now one more thing we can write it as stone hitting the object. Stone hitting the object with angle 45 degrees with the horizontal. So you can write tan 45 degrees is equal to Vy divided by the Vx. Vy by Vx value, if you write, Vy value is Gt minus Uy. Vx value is equal to Ux. As tan 45 degrees is 1, we can write Gt minus Uy is equal to Ux. Gt is equal to, you can write Uy plus Ux. Let us consider this is the fourth equation. Observe this carefully. Our unknowns are, x is known term actually for us. No, unknown terms are t unknown, ux unknown, uy unknown, and u is equal to under root of, you don't want u value actually, you want u bar value. U bar is equal to ux I cap plus uy j cap. Okay, and any other unknowns are there here. X is there, y is there, t. Okay, now by using this one, let us consider the second equation, y value. Okay, 1 2 3 and 4. by using 1, 2 and 1, 2, 3 and 4. 3 and 4 we can find t and u bar. Why? Because you want ux and ui also, no? We can calculate. This is a given data. If you calculate, you will get the t value is 1 second you will get. Okay. Similarly, u bar is equal to 3.75 I cap plus 6.25 j cap you will get. Take the g is equal to 10 meter per second square. So calculate that. These are the relations. Along x-axis, along y-axis, given condition I have applied. 10 marks question is this. Okay, you try this. If you want calculation, already I have given the calculation here. You can see first equation, second equation, I substituted new relations, we can see it. And finally, I got the values. Calculation part I have written here. You can see. This is actual calculation part. Okay, I am getting t is equal to 1 second, u bar is equal to this. Just you need to substitute the values, given values. Okay. Next question. This was asked in 1998 8 marks question. A large heavy box is sliding without friction down a smooth plane of inclination theta. From a point P on the bottom of the box, a particle is projected inside the box. The initial speed of the particle with respect to the box is u. And the direction, you can see particle is projected from u, P, and it is projected with velocity u. Box is initially does not have any velocity. Okay, it is sliding with g. Okay, and the direction of projection makes an angle alpha with the bottom of bottom as shown in the figure. Find the distance along the bottom of the box between the point of projection P and point Q. Point Q is this actually landing point where the particle lands. Assume that the particle does not hit any other surface of the box. Okay, first we will do the first question, then we will move to the second question. What actually happening we can see here. This is a box. This box is moving downward direction. You can see actually acceleration of the box is equal to g sine theta. As it is moving downward direction, it will have the downward direction. Now it is given that inclination is given theta. Okay, from this one point P, a particle is projected with velocity u. Initial velocity of the box, that is ub, value is 0. Now you can see initial velocity of the particle is there and it is reaching the point Q. Whenever we are taking this point, you observe this carefully. The velocity of the particle I am taking as a up. So up with respect to b is equal to along x-axis is equal to particle along x-axis initial velocity, that is u cos alpha. up b along y-axis is equal to velocity of the particle along y-axis. Reason is initial velocity of the box is equal to 0. Okay, u sin alpha. I am writing this is my u cos alpha and perpendicular to that is u sin alpha. Okay, next one. What are the g values? You can see g is acting downward direction for the particle. I am writing for particle. Now you can resolve into components. How these components will be there? Now we can resolve into components. One component as it is 90 degrees, 90 minus theta, this will be theta. Now we can write the g cos theta and another component is g sin theta. I am writing acceleration of the particle along x-axis is equal to minus g sin theta. Acceleration of the particle along y-axis is equal to minus g cos theta. Acceleration of the box along x-axis is equal to minus g sin theta. Acceleration of the box along y-axis, it is not moving. Now if I write the acceleration of the particle with respect to the box along x-axis, minus z sine theta minus of minus z sine theta, you will get 0. Means there is no relative acceleration along the x-axis. Okay. Now similarly, acceleration of the particle with respect to box along y-axis can be written as minus z sine theta, minus z cos theta minus 0. You can get the minus z cos theta. I got the ABY value also. Now you know that time of flight as y value is 0 for particle P to Q. While moving from P to Q, y value is 0. You can write T is equal to time of flight uy divided by the AY magnitude value, right? 2 into last video also I have explained this. We can check that. 2 into uy value is equal to, we can write it as u sine alpha divided by the, and AY value you can say that g cos theta. This is time of flight. You can see first question what they're asking. Oh, x value they're asking. So range PQ, x is equal to, you can write it as u particle along x-axis t plus half into apx into t square. As apx value is equal to 0, ap b with respect to, I'm writing with respect to x into t square, that value is equal to how much? 0. This also, whatever x is there now, position of the particle with respect to the box. This is also p along x-axis. Okay, all values I have written. This value all equal to the initial velocity of the particle along x-axis only. You substitute there, u along x-axis can be written as u cos alpha. T value is 2u sine alpha divided by the g cos theta. So finally you will get the range PQ value is equal to u square sine 2 alpha divided by the g cos theta. This is the range of this. First question answer that only. U square sine 2 alpha by g cos theta is the that we are getting. Okay. Now observe this. Second one, if the horizontal displacement of the particle as seen by an observer on the ground is 0, find the speed of the box with respect to the ground at the instant when particle was projected. Initially given that u, if the velocity of the box is equal to 0, this what actually you have observed question 1. Okay, now question 2, what they are asking, what velocity the box should move. Box should move so that whatever displacement PQ is there, no, that value is equal to 0. Okay, so to get that, box should move downward direction. So I have done the same thing here. I have done already same thing. You can see, to get the horizontal displacement with respect to the ground, box should move downward direction. Okay, then how it is moving you can see here. Let us consider that box is moving downward direction initially along x-axis like this, and the box is also having acceleration of the box along x-axis is equal to g sine theta is there. Now this particle, now whatever the p and q terms are there, now that range should be equal only. So now you can see here range should be 0. Okay, it should be reaching to the point q is there now, that earlier this point p is here. For box you can see here particle is projected with an angle alpha. Now p location, now q came because of this motion, because of this AB along x-axis is there now, that this q is coming here because this one is going downward direction. Now I am taking this box is moving with a velocity initially v0. Okay, this I am writing as at t is equal to 0. This is the situation. At t is equal to any time t, I am writing here. Time t already you know that time of flight. Okay, now you can write the, as they are moving downward direction, we can say x is equal to u box along x-axis into t plus half into acceleration of the box along x-axis into t square. Okay, that x value is a downward direction, that value is equal to range pq is there now, that pq value you can use the minus given values like u square sine 2 alpha by u square sine 2 alpha divided by the g cos theta minus v naught into t. Actually t value also already we have got, that value is 2uy by a 2u sine alpha divided by the g cos theta plus here along b axis minus half into g into sine theta into t square value you have to substitute. You substitute, just I have written already t square value also you have to substitute now. T square value you substitute there 2u sine alpha divided by the g cos theta whole square. Substitute there and get the v naught value. Okay, if you calculate v naught value you will get the some result. I did that calculation, this is easy calculation and you can see it. Finally I am getting like a u cos theta plus alpha divided by the cos theta. This is a calculation. You can check this calculation. Okay, I wrote all x term, v naught is downward, x is downward direction, displacement of the box along x axis is downward direction. Okay, ax also downward direction for box. Next question. You check the two guns situated on the top of a hill of height 10 meter. Fire one shot each with a same speed 5 root 3 meter per second. At some interval of time, one gun fires horizontally and other fires upward at an angle of 60 degrees with horizontal. The shots collide in air at P. Find the time interval between the firings. Second one is coordinates of the point P. Take origin of the coordinate system at the foot of the hill, right below the muzzle and trajectories in XY plane. This was asked in 1996. It is also 5 marks question. Look here, I am drawing now. Let us consider this is a hill. This foot of hill. It is a foot of hill. I am taking this as a reference line. X-axis. It is a y-axis. Y-axis you can see this is a y-axis. Okay, origin. From here, one bullet is projected. See, one bullet is projected. Let us consider bullet 1. This bullet 1 is projected with an angle of 60 degrees. Okay, and one more bullet was there from gun. It is projected horizontally with the same speed. They have given 5 root 3 meter per second. Here also 5 root 3 meter per second. 5 root 3 meter per second. Second one is projected. Whenever they are projected like this, we can see the first one, second one is going downward like this. First one will go upward and it will come down like this. Both are colliding here. Collide. Let us consider colliding particle from the ground is y distance is there and horizontal distance is how much here? X. In the question they are asking what is this x and y terms and what time they collide. That was actually question. Initially, according to question, we can see height of the hill is 10 meters. Okay, you can see total height is 10 meters. So from the point of projection, you can see that 10 minus y is the distance. Okay. Now to calculate this, we can see when they meet, when both the bullets meet, bullets or whatever stones are there meets, we can write x1 is equal to x2 and similarly y1 is equal to y2. Both are having same location. Some initial positions are same. You can see initial positions, final positions. These are final positions. These final positions are same and initial positions are same. So x1 is equal to x2, y1 is equal to y2. I am writing one by one. For bullet 1, ux is equal to, you can resolve this 5 root 3 cos 30 degree cos 60 degrees, you can write it as 5 root 3 by 2 is u1x. u1y, u1y value can be written as 5 root 3 into sin 60 degrees, you'll get 15 divided by the 2. I'm writing that only. u1x is equal to, for bullet 1, u1x is equal to 5 root 3 by 2. u1y value is equal to 5 into root 3. Sine 60 degrees is root 3 by 2. That's why I have written 15 by 2. And a1x is equal to 0. a1y value is equal to minus 10 meter per second square. Similarly, bullet 2, you can root u2x is equal to 5 root 3 meter per second. u2y value is 0. a1x value is 0. a1y value is equal to minus 10 meter per second square. I have all the values. You can use that when they collide. You can use that x1 is equal to uxt plus of axt square. That is t1. Okay. Similarly, ax1 value is 0. Now x2 is equal to ux into t2 plus half into ax into t square. The value is 0. We can write x1 is equal to x2. It implies we can write u1x actually. u1x here, u2x. u1x value is 5 root 3 by 2 into t1. u2x value is equal to 5 root 3 into t2. From this I can write t1 is equal to 2t2. I wrote the one relation. Similarly, y1 and y2 also same. We can write y1 is equal to u1y plus half ay1 into t square. Similarly, y2 is equal to u2y plus half into a2y into t square. You can write the y1 value, you can write it as from the diagram. If I take this is a reference line for the bullets, okay, I can write it as negative of 10 by 10 minus y is equal to u1y value is equal to 15 divided by the 2 into t, I forgot t, uyt t1 minus 5 into t1 square. Similarly, negative of 10 minus y is equal to u2y value is 0 minus 5 into t2 square is there. So from this you both equate this. If you equate this, what value will get? 15 by 2 into t1 minus 5 t1 square is equal to minus 5 into t2 square. Okay, y1 value and y2 value, if I substitute the values, you can see that how this 15 by 2 into t1 and minus values are there, we can see here. Okay, you substitute that t1 and t2, you substitute the t1 value here and the t2 value, t1 value, t2 value, and you can get the value of difference in time interval between the firings and point P, nothing but x and y coordinates you can calculate. If you calculate, you will get 1 second and 5 root 3 comma 5. Observe this carefully how I have done calculation. Just use these relations. This is one relation, this is a second relation. By using that only you will get all the values. T1, T2 values you will get, substitute that T2 minus T1 or T1 minus T2, you can do it. If you write T1 minus T2, first option you will get. Similarly, you need to calculate what their locations, where they are located, x1 comma y1 or x2 comma y2 value, x2 comma y2 you have to calculate. I calculated this. You can see that after substitution of above relations, I got the T2 is 1 second, T1 is 2 seconds, and the time interval is T1 minus T2 is 1 second. That calculation part you have to do it. Just substitution only. Okay. Next, coordinate of point P, you can write it as x value I wrote. Similarly, y value I wrote. I got the 5 meters is y is equal to 5 meters and x is equal to 5 root 3 meters. Finally, I am getting 5 root 3 comma 5. Okay. Next question. So here two towers AB and CD are situated a distance D apart shown in the figure. AB is 20-meter high and CD is 30 meters high from the ground. An object of mass M is thrown, you observe that mass is also they have given, is thrown from the top of AB horizontally with a velocity of 10 meter per second towards the CD. Simultaneously, another object of mass 2m is thrown from CD at an angle of 60 degrees to the horizontal towards the AB. With same magnitude. Same magnitude means initially whatever projection 10 meter per second is there now, same value. Towards the AB with the same magnitude of initial velocity as shown in the shown as that of the first object. The two objects move in the same vertical plane. See here, same vertical plane collide in midair and stick each other. Calculate the distance between the towers. Find position where the object hit the ground. Now you need to calculate distances. As in 3 points already I have given that how to calculate this kind of questions. We can make the 2 points like this. Point A and point B you can write like this. Separation between them is D. Making angle theta you write. If you observe that first case and second case I am writing now, this is my u1x, that is equal to 10 meter per second. My u1y value is 0. Similarly, my u2x I am writing, u2 is this 10. No? I am writing u2x is, I can write it as 10 cos 60 degrees. 10 cos 60 degrees is 5. Similarly, downward direction I can write it as 10 sine 60 degrees. I am writing my u2x value is equal to minus 5. u2y value is equal to, I can write it as 10 sine 60 degrees is 5 root 3. Okay. So I can write minus 5 root 3. What is my u1 with respect to 2 along x-axis? I can write it as u1x minus u2x. I can get the value is 10 minus 5. I will get the 15 meter per second along the u12x meter per second. Similarly, u12 along y-axis. u1 along y-axis minus u2 along y-axis. You can get the 0 minus of minus 5 root 3. So I will get the value as u12 value is equal to 5 root 3 meter per second. Now we can see this is my u1x value is 15. This is my u1y value is you can write it as just now you got 5 root 3. Making angle theta, and this is my u12 bar. Okay, I wrote a line along the line joining between the two projectiles as I have given theory earlier. The relative velocity should be along the line joining between initial positions of the two projectiles. Okay, and this height as per the question you can see one is 30, other one is 20. So you can this 20 and 30, this value will get 10. So tan theta value is equal to u1 2y. Okay, u12y divided by the u12x, that is equal to 10 divided by the d. Now you can see u12y value is equal to 5 root 3 divided by the 15 is equal to 10 divided by the d. I can get the value is 1 by root 3 is equal to 10 by d. I will get d is equal to 10 root 3. This is my distance between the towers. So 10 root 3 is the answer. Okay, you can write that value approximately 17.3 also you can write. Similarly, what they are asking, if they collide, at what time they are colliding actually? Time for collision. Time for collision. To calculate time for collision, you have to write the AB value divided by the U12 magnitude you have to write. What is the AB value? You see here, from this triangle, 10, D value is 10 root 3, sorry, this is theta, A, B, D value is 10 root 3 and here 10 is there. The AB value can be written as AB is equal to under root of 10 square plus 10 root 3 whole square. You can get the 20 meters. AB value is 20. What is the U12 magnitude value? U12 magnitude is under root of 15 square plus 5 root 3 whole square. 15 is 225 plus 75. We can get the 10 root 3 meter per second. Substitute there 10 root 3. You can get the 2 by root 3 seconds they collide. If they collide at 2 by root 3 seconds, now you can apply the conservation of linear momentum also you can apply. Okay, two projectile move in the same vertical plane. So I am applying along x-axis. You can apply along horizontal direction, no external force, no external force. So you can write it as initial momentum along x-axis is equal to final momentum along x-axis. M into first body is how much mass, M how much is given here, M. Second body is 2m. Okay, I am writing M into first body u1x value is equal to u1x only plus M into bar 2m into u2x bar is equal to M into v1x bar. They are sticking each other. So I am writing sticking here M plus 2m into their final velocity bar. Okay, now you can write M into u1x value is equal to, you can see 10, u2x is 5. So I can write the 10 I cap plus 2m into minus 5 I cap is there. That is equal to 3m into final velocity. As left side is 0, v bar is equal to 0. Finally they comes to rest. Whenever they collide now, whenever they are colliding like this somewhere, here I will write, whenever they are colliding somewhere here, they are coming to rest. Whenever they are coming to rest, we can see here, they are coming to rest and fall freely. They fall freely like this. Okay, now they are asking find the position where the object hit the ground. At what point they are hitting the ground, we can see horizontal distance we can calculate now. X is equal to ux into t. You can calculate and get the 10 by root 3 meters, 20 by root 3 meters. Observe this. I already calculated. You can see it. X is equal to just u1x into t. 10 into 2 by 3, 2 by root 3. Time taken already 2 by root 3 calculated now. You substitute there, you will get the value is 20 by root 3. Approximately 11.547 also. Okay. Next question we will discuss. Particles P and Q of mass 20 gram and 40 gram respectively are simultaneously projected from points A and B on the ground. The initial velocities P and Q makes 45 degrees and 135. So we can get these values also 45 degrees angles respectively with the horizontal AB as shown in the figure. Each particle has an initial speed 49 meter per second. Separation is 245 meters. Both the particles travel in the same vertical plane, undergo collision. After the collision, P retraces. Nothing but after collision, it is again coming back to the original position, and Q determine the position of the Q when it hits the ground. How much time after the collision does the particle Q take to reach the ground? Now you have to calculate after collision. The Q value is coming down now. This time you have to calculate. And one more thing, determine the position of Q when it hits the ground. This position also you have to calculate. What is this distance you have to calculate? Okay, and similarly you have to calculate the location, time also you have to calculate. Now for this, what you have to write? You just observe that 49 meter per second, making angle 45 degrees. Second ball also 45 degrees, making projected with 49 meter per second. Now you can write the 49 x-axis is u1x. I'm writing a, and this is a b. I'm taking u1, this is what here u2. u1x is equal to 49 divided by the root 2. Similarly, u2 u1y is equal to 49 divided by the root 2. You can write the u2x is equal to 49 divided by the root 2, and u2y is equal to 49 divided by the root 2. As per the question, you can see there is no relative velocity along the y-axis. If no relative velocity along y-axis, u1 2 along x-axis, you can write it as 49 by root 2 into 2, that is equal to 49 root 2 is there. That is a relative velocity along line joining between the initial positions of the axis. And separation between them is given, that value d is equal to 245 meters. Now you can calculate at what time they collide actually. Time is equal to AB, that is equal to D. AB distance is D divided by the U12 bar along x-axis. Now you can write the value is 245 divided by the 49 into root 2. So you'll get 5 by root 2 seconds. So they collide at 5 by root 2 seconds. Nothing but we can see, as their vertical components are same, both reaches their vertical positions at the same point. So at highest point they collide. If they collide at a highest point, you can calculate the maximum height. What is the maximum height formula? H is equal to u y square divided by the 2g. u1 y square or u2 y square, anything. 49 divided by the root 2 whole square divided by the 2 into 9.8. If you write that, 49 into 49 divided by the 4 into 9.8 meters, we'll get some h value. Okay, and the time taken when it will fall, first of all you have to calculate what velocity it is coming down. Okay, one particle is 20 grams, this is 20 grams, other one is 40 grams. Okay, conservation of linear momentum at highest point I'm writing. At highest point it will have like a u1x only, this will have u2x only, it will have. Okay, initial momentum along x-axis is equal to final momentum along x-axis. 20 into u1x bar plus 40 into u2x bar is equal to finally 20 into v1x bar plus 40 into v2x bar. If you see that whatever the first ball is there, no, u1x, and you can write 20 into u1x value is 49 divided by the root 2. I cap is there, I can write the both are same direction is there, that's why I'm writing u1x I cap, and minus 40 into u2x is equal to 49 divided by the root 2, that is equal to I cap, and 20 into v1x minus 49 divided by the root 2 I cap, and second one is 42 into v2x bar is there. You observe this carefully. 20 49 and 20 49 is there. If you bring that, 40 into 49 by root 2 into I cap minus 40 into 49 by root 2 into I cap is equal to 40 into v2x bar. We can say 40 into 49 by root 2, 40 into 49 root 2 get cancelled. So finally we will get the v2 x bar x is equal to 0. So q particle comes to rest just after collision. If you come to rest just after collision, it will fall freely. If it is falling freely, time taken t is equal to, you can write root over 2h by g. That's all. Already h value you will calculate here. G value 9.8. Substitute there, you will get the answers here. They are asking at what time it is falling down. Okay, I calculated here, you can see. Second particle comes to rest. Okay, for first particle height I calculated. Falling down time is 5 by root 2 seconds. Calculation, you can check this. Okay, next question. This was asked in JEE Advanced 2024 in paper 2 they have asked. A ball is thrown from a location x0, y0, 0, 0, horizontal playground with initial speed v0 at an angle theta naught from the positive x direction. The ball is to hit by the stone which is thrown at the same time from the location x1, y1, that is L, 0. You observe this. One particle x0, y0, that is equal to 0, 0. Particle A is projected making an angle theta naught with x-axis. Another side there is a particle which is located at x1, y1, that is L, 0, projected like this. Okay. Now stone thrown at 180 minus theta naught. If it is 180 minus theta naught from the positive x direction, 180 minus theta 1, so we can write this is theta 1 with suitable initial speed. Okay, the first one is initial speed is given v naught. This value you don't know. As you know, to collide actually you can say they have written already when theta naught theta 1 value they have given 45 degrees. This is also 45 degrees. To collide, there should not be any relative velocity perpendicular line. There should not be any relative velocity in perpendicular line. Perpendicular line to AB. I am taking AB. For that, you can write V naught into sine 45, 1 by root 2 is equal to V1 by root 2. So from this, we can write V1 is equal to V naught. Okay. Now, what is the time taken? What they are asking. The stone hits the ball at a time t1. Same thing they have in 30 and 60 and 30 degrees. T2 value how much? Now, time of collision. Time for collision we can write as T1 is equal to distance L divided by the U12 along x-axis. L value you can write it as L only and U12 x-axis you can write it as V0 divided by the root 2 minus V0 by root 2 is there. As per the question you can write L0 by 2 V0 by root 2, that value is equal to root 2 into V0. That is my T1. Okay. Similarly, in the next case, same question they have asked 60 degrees and other one is 30 degrees. 60 and 30. V0 and V1. Now you can write it as along y-axis, they should not have the any relative velocity. V0 into sine 60 degrees is equal to, this is a V1y and this is a V2y. V1 into sine 30 degrees. We can write V0 into root 3 by 2 is equal to V1 into 1 by 2. So you can write V1 is equal to root 3 into V0. Again, V12 along x-axis. We can write it as V0 into cos 60 degrees. Opposite direction is there. This is a U1x, U2x. Okay, I am writing that. Plus, we can write it as V0 into cos 30 degrees. V0 by 2 plus other one is not V1. Okay, V1 value is root 3 into V0, root 3 divided by the 2. So finally, root 3 into root 3 is 3. You can write it as 4 V0 divided by the 2. You will get 2 V0. Again, the time taken T2 can be written as L divided by the 2 V0. L divided by the 2 V0. If you write the T1 by T2 whole square, I am writing T1 by T2 whole square. If you write L divided by the root 2 into V0 divided by the L divided by the 2 V0 whole square, we can write L by V0, L by V0 get cancelled. Finally, 2 divided by the root 2 whole square. 2 by root 2 is nothing but root 2 whole square. We can get the 2. So answer is how much? 2. This is 2024 advanced paper 2. They have asked this question. Okay. Time for collision. One this I have done here also. We can see. Okay. One more question. One last question. Airplanes A and B are flying with constant velocity in same vertical plane at angle 30 degrees and 60 degrees. With respect to the horizontal respectively as shown in the figure. The speed of A is 100 root 3 meter per second. At time t is equal to 0 seconds, an observer in A finds B is at a distance of 500 meters. Observer sees B moving with constant velocity perpendicular to the line of motion of A. Now observe this carefully. This is A and B going like this. Let us consider that whatever they have given, we can see that this is the okay. First one, A is moving like this. VA is given that 100 root 3 meter per second, which is making angle 30 degrees. This is A. B is moving like this. This is the velocity of the B. Okay. Now we can see B is making angle 60 degrees. That's why I am writing a line parallel to VA bar. I have written this is 30 degrees and 30 degrees. Now I can write the parallel to VA bar. I can write the VB cos 30 degrees perpendicular to VA bar. This I can write it as VB sin 30 degrees. As per the question, B is moving. You see here, observer sees B is moving with constant velocity perpendicular to the line of motion, and separation value we can see that 500 meters. And there is no relative velocity along same line. There is no relative motion along parallel to line of A. Okay. Now we can say that 100 root 3 is equal to VB into cos 30 degrees. We can write 100 root 3 is equal to VB into root 3 by 2. We can write VB value is equal to 200 meter per second. Now VB sin 30 degrees value is how much? We can write 200 into 1 by 2, that value is 100 meter per second. Okay. Now this is a V perpendicular. Okay. Now we can see as per this, what is the distance between them? 500 meters. Now you observe this, what they are asking. At t is equal to t naught, A just escapes being hit by B. What is the t naught? To escape from this, it should actually be critical condition. If I say that B should what time B can reach the A? B can reach A in time t is equal to 500 meters perpendicular distance divided by its perpendicular velocity. So 500 divided by the 500 divided by the 100, you can get the 5 seconds. So it is being escaped in 5 seconds. You can see here, as per the question, they are asking that t is equal to t naught, A just escapes being hit by the B. What is the time? So this is the 5 seconds. This is also JEE advanced question only, previous year JEE advanced question. We can check this. Same thing, I also derived this and I got the same 5 seconds I wrote here. Okay. Just observe that whatever I have given. I hope you have understand this. You also can do the number of questions from the Irudo and other books also. There are multiple questions are there based on the time between the collision, and similarly condition for the collision between two particles, minimum separation between the two particles, and time for the minimum separation between the two particles. In the next lecture, I will explain the relative velocity in 2D, like river boat problems and rain umbrella problems. That problems are there, no? What they have asked in JEE means, I don't think so they asked in JEE Advance. If any questions are there in JEE Advance, I will see. But JEE means mostly they have asked questions. We'll discuss that questions. Thank you very much.